Hi, I'm Mike Antone, here to start a discussion on the effects of dams and flow regulation on green sturgeon, Acipenser medirostris, in the Sacramento River. I chose this location and this species because, as I was doing research on the imperiled North American sturgeon fisheries, I came across a paper on the effects of dams on this particular species, and it seemed like the logical direction to go. Industrialization depends on rivers for power, and many waterways became dissected with dams. Dams can block access to spawning reaches, resulting in population declines and ultimately extirpations. Few large rivers are undammed. It's estimated that in the United States there are more than 80,000 dams 6 feet in height or more, as cited by Lindbergh and Waldman 2009. By way of an example, the Hudson River watershed contains 797 registered dams, Swaney et al., as cited by Lindbergh and Waldman 2009. Engineered solutions for fish passage in the form of ladders and lifts have been fitted to some dams, but generally passage is species-specific, and the number of fish traveling through these engineered passages is far fewer than it would be in the absence of dams, Lindbergh and Waldman 2009. The Sacramento-San Joaquin River Basin is currently the subject of several large-scale ecosystem restoration programs that aim to recover anadromous fish populations, including the North American green sturgeon. The green sturgeon is known to spawn in only 3 rivers, the Rogue River in southern Oregon and the Klamath and Sacramento Rivers in northern California. Mora, Lindsay, Erickson, and Kimley 2009. Like most sturgeons worldwide, green sturgeon are of conservation concern. The northern population that spawns in the Rogue and Klamath Rivers is considered a species of concern by the U.S. National Marine Fisheries Service, and the southern population that spawns in the Sacramento River is listed as a threatened species under the U.S. Endangered Species Act. Research by Mora et al. 2009 supports the belief that spawning areas are at the upstream most reach of the green sturgeon's spawning migration, and that they may move some distance back downstream after spawning and before migrating back to sea. The Shasta Dam and Reservoir block access to reaches of the Pitt, McCloud, and Little Shasta rivers that contain suitable habitat for green sturgeon. Similarly, Oroville Dam and Reservoir block some areas of suitable habitat in the Middle Fork of the Feather River, and Dougherty Point Dam blocks some habitat on the Yuba River. These same dams have been implicated in the extirpation of many populations of winter and spring run Chinook salmon. Yoshima et al. And Lindley et al. As cited by Mora et al. 2009. Dams have numerous other effects on rivers that may affect diadromous fishes directly or indirectly. Among these are the blocking of normal movements and changes in the community composition of resident fishes that interact with diadromous fishes, microevolution of populations isolated by barriers, pronounced alterations of water temperatures upriver and downriver, retention of nutrients and sediments, and even where fish passage is successful, the imposition of the need to cross sometimes large, unnatural, stillwater habitats. Helfman, as cited by Lindbergh and Waldman, 2009. Dams that are operated for hydroelectric generation also cause direct mortality, death by turbines. Helfman, as cited by Lindbergh and Waldman, 2009. Adams, Grimes, Lindley, and Moser, 2002, noted a significant number of juvenile fish lost to pumping operations at water export facilities in the Sacramento Delta. Reservoirs and dams trap sediment and reduce peak flows, altering channel morphology and the distribution of sediments, with profound effect on spawning, rearing, and holding habitats for green sturgeon. To this point, flow regulation has been implicated in the decline of many sturgeon populations in North America. Furthermore, reservoir release make downstream reaches cooler in the summer and warmer in the winter, disrupting what would be suitable habitat for green sturgeon in the absence of reservoir releases. Mora et al. 2009. I look forward to your questions and the conversations that will follow.